Okay, again, there are two ways to write formulas for a given sequence. One way we talked about in a previous video called explicit formulas, and that was where if I want to know the fifth term, I plug in 5 for n. But the other way to write a formula for a sequence is what's called a recursive formula. And a recursive formula means that you write a formula that is based on what you do with the term before to get the next term. Okay, so sometimes it's difficult to write an explicit formula for some sequence where I can't just say, hey, I'm going to plug in 10, that's going to give me the 10th term. Instead, we can write those formulas recursively, which says if I want to know the nth term, all I have to know is the term right before it, the n-1 term, right? So a couple things. With recursive formulas, you have to be given a starting point. So this first term has to be given, and it tells me that, in this case, a sub 1 is 1. I know the first term of my sequence is 1. Then it says every term after that, a sub n, is defined as 3 times a sub n minus 1 plus 2. Okay, so what's that mean? Well, if I want to find the first 5 terms of this, again, I know it tells me that the first term, a sub 1, is 1. A sub 2, the second term, would be 3 times a sub... Now what I'm going to do is I'm going to plug in 2 for that n. So 2 minus 1 is my subscript here, and then plus 2. Well, what is that? That's 3 times... That would turn into a sub 1 plus 2. Well, what is a sub 1? A sub 1, I know, up here is 1. And so what I end up with is 3 times 3, which is 9. Well, a sub 3 would be 3 times a sub 3 minus 1 plus 2. So that's going to be 3 times a sub 2 plus 2. Well, what is a sub 2? A sub 2 is 9. We just figured that out. So that's 3 times 9 plus 2, which would be 3 times 11, which would be 33. Okay, so I hope we're seeing a pattern, and that pattern is this a sub n minus 1 part, that is simply just being replaced with what was the previous term value. So when I go to find a sub 4, instead of actually working through that, I'm just going to say, hey, I know that in that place, a sub n minus 1, I'm going to use the value of the term right before it, which was 33. So that's going to give me 3 times 35, which is going to be 105. Right, and if I want to find the fifth term, I'm going to do 3 times 105 plus 2. Right, I'm using the term right before it. So that's going to give me 3 times 107, which would be 321, and so forth. Okay, so yes, you could work this out like I did the first two, and you could plug in whatever number term you're trying to find. You could plug that in for n and then simplify that down. Or you can just know anytime you see a sub n minus 1, that means the previous term. The previous term plus 2 multiplied by 3. That was my recursive formula here. So I know that my sequence would start 1, 9, 33, 105, 321, and so forth. Now, what's the drawback for a recursive formula? Because a lot of times that's kind of easy. All I need to do is take my term right before it and do some stuff to it, and I get the next one. The drawback is if I want to know the 50th term of a recursive formula, recursively defined formula, I have to know the 49th term. Well, that requires me to know the 48th term. And I would have to know every single term before that to get to that 50th term. An explicit formula, you don't need to know that, right? An explicit formula, if I want to know the 50th term, I plug in 50, and I work out the formula, and it gives me the value of the 50th term. So that's the drawback with recursive formula, is that it's so built on what was the term before it, and you have to know those things to get your next term. Okay. Now there are some sequences where we could use both an explicit and recursive formula. So that's what I want to show you here. I've got a sequence 3, 7, 11, 15, 19, 23, so forth. I want to write both the recursive and explicit formula for this. So the explicit formula, again, is in another video. Check that out if you are unsure how I'm doing this. The explicit formula is, I want to come up with some formula where I can plug in for n. I can plug this in, and it's going to give me the value here. And something that we had for an explicit formula was if we noticed that our pattern was linear, meaning that I added the same thing every time, which in this case I can see that we're just adding 4. Our formula is going to be that is the slope. And then what I have to figure out is what do I still need to add or subtract from that to get to the last term here, or to the term value. So if I plug in 1, I'm supposed to get 3. Well, 4 times 1 is 4, so I still need to subtract 1 to get to 3 there. But that'll work, right? If I plug in 2, 4 times 2 is 8, minus 1 is 7. 4 times 3 is 12, minus 1 is 11. 4 times 4 is 16, minus 1 is 15, and so forth. It does work. Every time you write a formula like that, I would check the first few terms just to make sure it's working every time. But that's our explicit formula. A sub n equals 4n minus 1. The recursive formula. Again, there are a couple things that you need for your recursive formula. First, with a recursive formula, you have to state what the first term is. The first term of our recursive formula is 3, because everything's built on what was the term before it, so I have to have a starting point. Then, the next, for every other term after that, what am I doing? Well, with recursive formulas, again, you're just looking at what are you doing to get to the next term. I'm just adding 4, right? So, the way I'm going to say this is take the term before it, which is a sub n minus 1, and then add 4 to that. A sub n minus 1 plus 4 is going to give me the next term. 3 plus 4 is 7. 7 plus 4 is 11. 11 plus 4 is 15. So that is how I would write that recursively. A sub 1 is 3. A sub n is a sub n minus 1, the term before it, plus 4. So some sequences we can write both formulas for that, and you may have a choice sometimes. However, sometimes you may have to stick with just one because the other one is nearly impossible to do. So being able to look at a sequence both explicitly and recursively is a very good skill to have.